Let us see some problems on buoyancy. In buoyancy, only from basic concepts the problems will be asked. So we will see which type of problems will be asked in GATE and ESE. So the first question is, the cylindrical body of cross-sectional area A, height h, and density rho s is immersed to a depth h in a liquid of density rho and tied to the bottom with a string. The tension in the string is. So this question is asked in 2003 GATE, and for any question, the basic concept should be used. The basic concept is buoyancy force is equal to weight of the fluid displaced. Buoyancy force is equal to weight of the fluid displaced, and volume of fluid displaced is equal to volume of body immersed. So these two should be remembered. And what is the weight of fluid displaced? Density of the fluid, acceleration due to gravity, and volume of fluid displaced. So remember these both. With these both, we can solve any type of problem. So the question is cylindrical body of cross-section area. So this is cross-sectional area A of height h. The height of the cylinder is h, capital H, is immersed, and this density is rho s, immersed to a depth h in a liquid of density rho. So this is immersed into this. Suppose this is the free surface and there is some liquid. This density is rho. So this is immersed to a depth of small h and tied at the bottom with a string. So here it is tied with a string here. So the tension in the wire, let us say T. The tension in the string is. So we need to find the T. What are the forces that will be acting on this? The forces that are acting are, one is weight, which is acting downwards. Other is buoyancy force. So if we balance this, if we draw the free body diagram of this, weight is acting downwards, buoyancy force upwards, and the tension. How do we take the direction of tension? If we draw the free body diagram, the tension should be always outward from the body. So this is tension, and downward forces on left side. So T is downward and W is downward, and upward forces on the right hand side. So this is the force balance equation for this free body diagram. We need to find tension. Tension in the wire is equal to FB minus W. So here what is W? W is the weight of the body. So buoyancy force is equal to what? Weight of fluid displaced. Weight of fluid displaced. What is the weight of fluid displaced? Rho F, density of fluid into acceleration due to gravity, and volume of fluid displaced. What is the volume of fluid displaced? This much amount of the volume is displaced by this body. So that is volume fluid displaced is equal to this area into small h, and Fp buoyancy force is equal to, what is the density of fluid? Density of fluid is given as rho, acceleration due to gravity g, and volume of fluid displaced is A into h. So this is Fp. What is weight of the weight of the body? This is weight of the body. So weight of the body is equal to rho v into g. So density of the body is it is given as rho s, and volume of the body, total volume of the body, which is area into capital H. Area into capital H into g. If you substitute this both in this equation, let us say 1. So tension in the wire is equal to buoyancy force rho g ah minus weight of the body rho s a h g. So if you take common, you can take g and a common, and rho h minus rho s into capital H. So this is the tension in the wire. So the option D is the correct answer. Next, let us see another question. this type of question may be asked. Mostly simple questions will be asked. Sometimes these typical questions will be asked. A large vessel, as shown in the figure, contains oil and water. The body is submerged at the interface of oil and water such that 45% of its volume is in the oil, while the rest is in the water. The density of the body is, the specific gravity of oil is 0.7 and density of water is 1000 kg per meter cube. Acceleration due to gravity is 10 meter per second square. So in this, the volume displaced of oil is equal to 45%, 45 by 100 of volume of body, and volume displaced of water is, the remaining part is 55%. So 55 by 100 into volume of body. So these are the volumes of body displaced. So how do we find this densities? So this is the body and this is interface. So both the fluids, oil and water, both exert buoyancy force. So here buoyancy force due to oil, and here there will be buoyancy force due to water, and also there is weight of the body which is acting downwards. So we need to balance all this. Weight of the body is acting downwards, which is equal to buoyancy force due to oil plus buoyancy force due to water. So what is buoyancy force? Buoyancy force is equal to weight of fluid displaced. Weight of fluid displaced. So weight of fluid displaced due to oil is rho of oil G into volume displaced. Volume of oil displaced. So what is density of oil? Density of oil, we can find it like density of oil by density of water is equal to specific gravity of oil. So here density of oil is equal to specific gravity of oil into density of water. So density of oil is equal to specific gravity is given as 0.7 into density of water is given as 1000 kg per meter cube. So 700 kg per meter cube is density of oil. So 700 into acceleration due to gravity is 10 into volume of oil displaced. How much volume is displaced? 45 by 100 into volume of body. The total volume of body, I am writing it as VB. And what is the buoyancy force due to water? Density of water into acceleration due to gravity and volume of water displaced. And density of water is 1000 kg per meter cube, and acceleration due to gravity is, it is given as 10 into how much volume of water is displaced? 55 by 100. 55% of the volume of body is displaced. Now W is equal to buoyancy force due to oil, which is 700 into 10 into 45 by 100 into VB, plus due to water 1000 into 10 into 55 by 100 into VB. And weight can be written as weight of the body. This is the weight of the body, that can be written as density of the body into acceleration due to gravity into volume of body. And now we can cancel this acceleration due to gravity. This is acceleration due to gravity. This is acceleration due to gravity. VB, we can cancel all. So the remaining is density of the body is equal to 0, 0, 0, 0 cancel. Zeros, zeros. And the remaining is 7 into 45. So 7 5 is 35, 7 28, 31. So 315 plus here 550. So 5, 6. So 865 kg per meter cube is the answer. So mostly these type of problems will be asked